Hello, welcome back. So we're at this point, we have the geometry, we drag and drop here the mesh, remember to save it every now and then, and we're ready to move to the meshing stage, okay? But before moving to that, let me show you the case that you already have now, the workbench. I open it here. So this is what I prepare, okay, previously. So see that in this case, I generated different geometries, okay? So I have a geometry with symmetry, with no symmetry, and then I have these two. See here that I duplicated, but I could have just link this one to this one without duplicating this one. So it's up to you, okay? So, but see that here, different geometries, okay, and different meshes. So I have here a structure type mesh, it's fine mesh, it's a wall resolving. Then I have with no symmetry, okay, again, same stuff, will be larger, now twice this one, okay? Then I have with symmetry structure mesh, wall modeling, okay, wall function, and then a structure mesh, okay, wall modeling. So I'm going to show you how to generate these two, okay? There is a difference now between the structure and the structure. So a structure probably I'm going to give you best solutions, but these one are much easier to use. And I think honestly, today's software, solvers today, they can handle with no problem any kind of cells without losing accuracy, okay? So my advice is to stick with this instructor meshes. But if you can afford these meshes, yeah, you can use those meshes. So see that after you generate the meshes, you connect to Fluent, and then you generate here, you know, you export it to Fluent, and you are ready to go. So just let me close here and let me go back here. So let's go to the meshing tool. So to open this one, just double click, okay? So here there is only one option, so you need to right click to select different options, so just one, okay? So it will open the meshing, and when it's open the meshing, probably it's going to show you some highlights on the screen there. I already hide that screen, okay? So we're going to see that there's a few small differences, but it's not a problem, okay? But the first sense, you see here that it imported the mesh, okay? The surface that you created in Design Modeler, you have it here, and now you can mesh it. So remember, always when you have the lighting here, means that requires generation or requires to update it. The same will be here. See that you have a lighting there. Okay, so when you see a lighting there, it means that you need to update it. If you see a red symbol, means that is something wrong. So try to avoid red symbols, or if you have a red symbol, requires attention that you need to fix something. So if you press generate, it will create a mesh. Okay, but it's a very bad mesh. Okay, so remember that we have the boundary layer, see that one single cell, so this is not okay. It's not a bad mesh, but it's not okay for the physics that we want to solve. So if you click here, here's you have the options. So very important, by default, probably, I think in your case also, the physics of preference, Ansys measure will propose you a mechanical solver, a mechanical measure. So here just change it and use CFD, okay? So the parameters is a little bit different. CFD, and then you have solver preference. You can choose between these three solvers, choose Fluent, okay? So this is the first things that always you need to do, okay? You can also set up the default value. So somewhere here, I think in file, see that you have preferences somewhere, options. You can set up those values here, okay? So see that default physics preference. Also, you can set units here. So you have Design Modelers, you are in Design Modeler, you can set up your default values, just to show you that. So we have these new options. See that now you have again the lighting, and means you need to generate or update it. You have a different mesh, still it's not good. But now we need to, as you can imagine, we need to add sizing, okay? Different sizing functions, smaller cells. But you see in your screen, you see that circle around my cursor. That circle that you see there is the dimension of the largest cell in your domain. This is very useful, okay? It's already telling you that dimension. And that dimension, that is a global parameter and can be controlled here. See here that one corresponds to 0.35 meters. So let's put here 0.1 meter that correspond to the diameter, and see that you have it there. So one the radius, 0.05 maximum cell. So here you can already start to choose the maximum cell dimension, but remember you have global and local. So usually you put here a global parameter. Do not put something very small because that is global and will be all around the mesh. Remember, later you want to add local. So I will put 0.01 meters there. It's okay. So this is global parameter, and now you can go generate. See that it's slower, and see that you have this. Okay, much better mesh. Okay, look nicer, perfect mesh. But again, remember that we have the boundary layer there, so we need to add some refinement towards the wall. And when I talk about a structured mesh, it's basically this. So let me fit to screen here. Is this that the meshes are uniform? Okay, are quads or X's, and they are uniform. Okay, so these are the best cell types that you can use in CFD, but sometimes for industrial applications, it's very difficult to get something like this. But don't be afraid about this, about using triangles. They work as also well. Okay, so to control this, okay, so let me, you are here. Also, by the way, here, as you go here, a statistic, you can also get the statistic of the mesh. You have some advanced options. I'm not going to talk about this. However, I always invite you to read the help. You have the help, online help, and there you are going to have explanation of these options. But for the moment, these are advanced options that rarely you are going to modify. Okay, so to add a different method or sizing function, you right click here and see here, insert. And let's insert a method. You select the body, okay, see that it's a single body. That's what is important when you create the geometry, to have a single body, but otherwise you have multiple bodies and it's not easy to do the mesh. So you select, in the case of 2D, you select the surface, and then here you can choose different methods. So see that here you have quadrilateral, dominant, or triangle. Let me show you. See, I choose triangle. So this will be a triangular mesh, what is called a fully unstructured mesh. Okay, so see that is different from the other. Probably it's prettier to the eye. I don't know. It depends of your taste. But this is what is called a fully unstructured. Instead, when you have quads and they are perfectly aligned, these are a structured type mesh. Okay, so these are the best meshes, but they are not easy to generate. So let's work for the moment in this one. So see that you have here the options, quadrilateral, dominant, and let's force also to be everything quad. Okay. Generate. And we're done. So see that you insert here, see that you have many options. So see that you have the most important option. You can insert a method like the one we did, and then sizing functions. Okay, so if you insert a sizing function, you can change the dimension. Now this is local. So if you select the whole surface there, and now let me put here, I want a dimension there of 0.05. Again, see the circle there, that circle is telling you the dimension. So see that this local, if I go here, this local will override the global. Okay, so again, it's a little bit slower, but because you have smaller cells, putting more cells, more points in your domain. So you can get an idea. I know these are 2D meshes, not too many cells. So as you start to do stuff like 100 million cells, since our expenses are heavy, even if it runs in parallel, it tends to be a little bit slow. So it's doing the meshing. It's taking a long time. Okay, it's strange. Okay, so 70%, 80, 100, and we have it here. Okay, so see that somehow it seems that it's smaller. Okay, but see that it's not fully structured. Okay, the lines there are not 100% straight. So I'm going to show you, how to correct that, how to get that selection. But here you see that you can control that. Let me put it back to 0.1. That one a little bit small. What else you have seen now? Yeah, you can control locally, and you can apply this refinement in the whole surface, in the body, in an edge, okay, or around a vertex. So see that I'm going to insert sizing, and see that here you have the type of selection that you want to do. I want to select an edge, select this edge, and see those yellow lines there represents this size of the element. So I will put there 0.005. Generate. And this is what we have. You see that you are controlling now locally here, and then you have the global value. So this is fully on structured mesh. A structured mesh what it will do is that you define a dimension here, and everything will be propagated in the whole domain. Okay, but you need to force that kind of mesh. Okay, so let me suppress you here. You see here, suppress. I don't want to use that option. So again, as you generate, it will generate just using this edge size and the global sizing parameters. Okay, but if I want to propagate this size in the whole domain, there is another option. So I go here, insert, see that you have phase meshing. Select the whole domain, apply. Here you see you force the type of element, so you want quadrilaterals, generate, and see that now you have it here. Okay, so this is what is known as a structured mesh. Okay, so you have it. You have that propagation. Okay, so now let's see that also you can change the sizing in these two edges. So let's add another sizing. Okay, select this and these edges. Okay, because they are the same, so you can select with control two edges and give a dimension. Okay, so you can give an element size or the number of divisions. So I will say that I have 500. No, let me see that I have 800. Now let me see that I have 1,000 elements there. If you do 1,000 elements like this in 3D, it's a lot of cells. You will see that very fast it will go to something about 5 million cells. Okay, so see that 1,000 cells in the whole domain. Okay, and generate. And we have this. Okay, we have our division in the whole mesh. Okay, so now that we're happy with this, let's do also something that, remember that we want to resolve the boundary layer in the top wall here. This will be the symmetry axis. So we need to cluster more cells here. So how do we do that? Again, we can do like, okay, we have here already this edge size. We can increase this one. Let me increase to 0.1, generate. Okay, see that now it is smaller. And now what I can do is just to control the stretching, to stretch more cells here. But see that also the dimension, this dimension in X is not being kept constant. So there is something that when you're doing these kinds of measures, I recommend you that here, when you put the edge sizing behavior, force that behavior, not put it hard there. So when you put it hard there, you are forcing to have that specific dimension. Okay, so I always recommend you to do that. And same here also. So in all the edges, just force that behavior when you are doing this kind of meshing. Now, see that now we have this, perfect, beautiful. So now how do we control this stretching for this kind of meshes? So see that here you have an option called bias. So now let's control the bias. So I want to bias, you have different options there. And let me add a bias factor of 4. Again, in the documentation, you will see how this bias factor is computed. I don't recall that it is a function, maybe a power law function, I don't recall. But see that this is just clustering more cells there. You have many different options. Okay, so you have this one that it will go to the other side, or probably you will have it toward both sides edges. Okay, so it's up to you to choose to pick up the right one. So for me, this is the right one. Generate, and see that you cluster your cells there. Okay, so still, but what is interesting that now look at that. If I go to the other extreme, see that I don't have the bias here. So also I need to apply another function. So let's use this one here. And let's say that, let me duplicate this one, change the edge selection. I want to select this one. Okay. So I don't recommend you to select these two edges, because see that now this bias function, it is different. So you have to be careful with that selection. Okay, so now I choose this one. Okay, so do not do the selection and duplicate both, because the extremes tends to be opposite the bias. So that is difficult to control. So it's better to do it individually. So see that you have the bias there, and this is it. This is the mesh. Okay, so now at this point, just go crazy. Okay, you can change, put cluster cells. So we have seen in the theory how to compute the integral length scales, also how to estimate the y plus value and the first cell center. So for instance, here we have this one. So if you want to measure a distance in this mesh, see here that node selection, and select from here to here. And this is the distance from here to this node. Okay, so you have this distance, and remember that is the cell center, the solver is cell center. So you divide this one by 2. Okay, so you have this distance, you can compute your y plus value. Okay, we know our Reynolds number. So I mentioned that in this case, we want to run the turbulence case to a Reynolds of 100,000. Okay, so I already know that this distance should be in the order of 10 to the minus 5. Okay, you see it's very, very, very small. So just to remind you here, 100,000. Okay, so that can be controlled. Okay, so what I need to do is remember that you have these parameters. Okay. Okay, so let me go here, and to control that one, you can increase the bias factor. So here we'll put it in 10 to 10. Okay, so let's measure this distance now. So we need to increase also the number. So let me go here, 0.5, generate. A little bit slow. So one thing that just to show you, when you do the instructor mesh, it is much easier because oops, what problem? Okay, I need to update this the opposite also. So remember that they are linked. So see that you get this symbol is telling you that you have a match between the edges, so the phase meshing is not working fine. So you need to have the same number of cells or same space in both in all extremes now in order to do these meshes. So let me go from here to here. So you are there. So let me increase a little bit more this one to 20. Okay, so that one should have that value. So let's see what we have now. Okay, so now that one should be about that value that we're looking. Okay, so it will be 0.03. Okay, let's say that we're happy with this value. Probably I can increase this one. Let me increase to 0.2. Let me increase here also to 0.2. Okay, so in this case, see that you can control everything. You can estimate your distance first cell center. You have the formula. Okay, we know our Reynolds. So let's do it like this. Okay, so this one should do the trick. Okay, so let me see. Okay, so if I click here and here, okay, that is about right. Okay, so we're there. So see that verify mesh that we have, and also check the other extreme. Okay, so we have this mesh. Always control the number of cells. So you have, okay, 250,000 cells. Probably I had it too much, but let's reduce. Instead of using 0.0, let's put 0.05. Okay, this is okay. Okay, but so this is a little, it's up to you to play with the parameters. Okay, you know how to estimate your distance. Also, you need to keep the cell count within the maximum number of cells that you can use. That is a little bit more than 500,000 cells. Okay, so this is what we have. This is, by the way, this is a very, very, very fine mesh in 2D. Okay, so in 2D you can afford this, it's very fast. Okay, so now we're ready to run. So let's check again 100,000 cells. But before running, remember that we need to define boundary conditions. Okay, to define boundary conditions, okay, you need to select edges, assign names, and we haven't done that so far. So to do that, in this case that is 2D, we can select edge. Let me select this one. You select that one, right click and see here, create name selections, and give it a name, inlet. Now let me do it here. So this will be outlets, and here the bottom one will be symmetry. So these are the names, so I misspelled there, so it doesn't matter. Then there I will call it wall. Okay, so you have this, name it selections, and you have all your edges. In this case in 3D will be surfaces. Okay, so you can rename it there or you can erase it, it's up to you. I will call it sin. Okay, so now we have the whole definition. By the way, if you forget or if you don't select an edge or surface, Fluent will put it automatically in a default group. Okay, will be by default will be a wall. Okay, so in theory here we don't need to select this wall because Fluent will put it. Even we don't need to select this and this because Fluent will put everything in a default wall. Then you select this two wall if you are not using symmetry, but you need to select this inlet and outlet to assign there. So this is it. This is the mesh. So again, you go here. Now you close. It will save the mesh. So you go back here. Remember view. Well, you can leave it here. See that now you have a new file here. This is the mesh. But this mesh, it is in Ansys measure format. So you need to convert it to Fluent. So now you need to connect this mesh to Fluent. So as you go like this, and see that now you have the light in there, meaning that you need to update this. Right click, update. So this update is simply converting this mesh into Fluent format. See here that you have the location. So remember that whatever you put these files, in my case I'm working in the desktop, you enter here and you will see all the files, okay? So let's wait while it's doing the mesh, the conversion. So see that it's converted and see here that you have the new mesh. Okay, so this is the Ansys Fluent mesh. So as you go back to that folder in Sys, see that you have it there. Okay, so something that I would like to mention that I don't like to work here in the Workbench. So I will do later the setup here, but then I will show you how to set up the case outside the Workbench. And why I don't like to do this, because you see here, it is saving too much file information. When you're running large simulations also, the meshes are too large and it's saving a lot of backup data. So I don't like to work here, and it tends to be a little bit slower because you are using more memory. So I like to run in the Fluent isolated. I will show you later how to do it, but I will set up the first case here. So we have the mesh and Fluent. So let's say that now we want to create a second mesh. Okay, so I'm not going to run the case. Let me erase here. Okay, use erase. Okay, so see that the mesh was erased, and let me duplicate this one. Okay, so it is duplicating what we have done. So all the options, everything that you put it there, name it selection, it will be duplicated. And let me rename it. Okay, and I will call it instructor. So let's run this one. Okay, so this is the structure and this is the instructor mesh, and let's redo the mesh in here. Okay, so we'll select different parameters just to show you how to do the mesh, okay, using the instructor options. Okay, as I mentioned, this, as you see, that mesh was beautiful. These are the perfect meshes that we want, but that is the section rather than the rule, that kind of meshes. Okay, so we're here, we're back here. So we want to erase everything that we have here. So you go right click, clear generated data, and actually I don't need any of these options. Okay, erase everything. The name it selection remains. Okay, So there is no need to redo that. So automatic method here, let's choose triangles, and let me choose here on suppress, and let me choose that sizing seems to be all right. So see, as we don't put that option, the face matching option, okay, this one, the face meshing is not doing any, it's not forcing to have this instructor mesh. So we can have this nice triangular mesh. Again, the idea is the same, okay? So you can increase, okay, you can add sizing functions here, but here, when you add a sizing function, does not propagate in the whole domain, okay? So for instance, just to show you, if I put a sizing here, okay, so let me insert a sizing there, and let me put 0.01 there. 0.5, okay, and generate. It's just, you have it here close to the wall, and then there is a growth factor that, see, that is transition from this to the global value. That transition from the small to the large is controlled by this growth rate, okay? So basically 1.2 means that the cells are increasing in area or volume by 20% when you move, okay? So it's up to you. So the smaller the values, okay, this lower this transition will be. So let me show you 1.05. Okay, so sometimes 1.2 value is a good value, okay? So see here, clearly you see the influence that now it's a slower transition, okay? So let me erase this edge sizing that I don't want it there, but I want to add an edge sizing in this top there, in the top, and I want to put there 0.005, okay? So basically here we'll go from 0.005 to 0.1, okay? And see that now you have a nicer transition there, okay? You are selecting the whole edge, and see that then you want to control from here to here, you just change the growth rate. So this is a beautiful, nice mesh, okay? So now how do we add the boundary layer? So when you are doing instructor meshes, adding the boundary layer is different. There is another option. So as you go here, insert, see here that you have inflation. So it's usually here, most of the software will call it like this, inflation layer or boundary layer. So see that first you need to select the scoping method. Where do you want to grow this boundary layer mesh? You select, okay, it's a body selection. It's not a surface, body selection, the body, and then I want to grow that boundary layer. Okay, you can choose geometry name selection. I will choose this edge. Okay, so in this edge, you are going to grow upon this inflation layer using these layers, 2 layers. Okay, so we have seen from the tutorial also that it's a good idea, depending if you are doing if you are using wall function, it's a good idea to put at least 5 to 6. If you are wall resolving, you need to put there a lot of cells. So let me put here 10. Okay, the growth rate is the idea of the previous one that we just explained. So I put here this. Okay, and inflation layer. Okay, selection. Okay, I didn't select anything, so see that now you have there the selection, one edge. And this is what you have. Okay, so as you see, it's much easier to control, and it adapts very well to any kind of geometry. If you have crazy geometries, curvature, it adapts very well. So for instance, and what I mentioned that this one is easier to control. So you have different options, inflation option. So smooth transition, what it's doing is doing a transition from the smallest cells to the largest one, okay, to keep a smooth transition. So you don't smear gradients, okay? The problem is that you have a large transition, the gradients, you're going to have a problem in the accuracy of the gradient. So the smooth transition is controlling that. But for instance, is you know the distance from the wall to the first cell center, you can change that option. Instead of using that one, the default one that works very well, you can have more control. First layer thickness, and let me say that I want to have this. Probably it will be this, okay. And see that you have it there. your boundary layer. So you can go here and measure, and it's from here. Okay, sorry, it's here that you need to select from here to here. Okay, see that when you give the distance in here, you're giving the distance of the edge, then the cell center will be half that. Okay, so you have the distance, but see when I mentioned the growth rate and the transition, that this is really bad. See that from very small cells you go to large cells, and here you're going to have problems computing the gradients. So what you can do is that have smaller triangles here, okay, or you can add more layers. That probably here will be easier to control adding more layers, okay, but it's up to you, but usually you add there. So this is the price that you pay. We have seen when you want to resolve the boundary layer, you need to add a lot of layers also to control that transition between the inflation layer and the external cells. And see that much better, okay, but still we can do better. Okay, so let me go here and let me put 30. So on my personal experience, usually 30, no more than 30 you need. So see that 30 actually is too much. Okay, this is not very nice. Okay, actually you can use it, but it's not very nice because here, see that here, you are not putting too many cells. Okay, so let's keep that around 24. Okay, then also you can play with the growth rate. Okay, I could have changed the growth rate instead of reducing. So let's see that. Okay, so see that this one is okay. Okay, so let's take this mesh for granted. Okay, this is a good one, and let's run also in this mesh. Okay, so see here that this is much easier. You saw that this workflow is much easier than the structure one. The structure, even the structure was easy, but imagine that now that you have more complicated geometries, and not even more complicated. Imagine that you have a T, another pipe coming here. Just getting that pipe in a structure mesh is tricky. Instead of structure meshes, just give global local parameters, grow the boundary layer. So we're going to do something like that in tutorial 3 and 4. So now that we're done here, let me see the mesh count. So see that even that we have, probably we have better control in the boundary layer. See that we have less cells than the other. Usually also structure meshes have the tendency to use more cells. But in any case, everything can be controlled. So see that now you have the two meshes. And what you need to do now is to convert everything to Fluent, or the solver that you want to use. If you want to use CFX, you put it there. So we want to use Fluent, put it there, update. So now you're transferring this mesh to this solution. This is a structure mesh to this solution. And now also after this is done, okay, you see that lighting always means that you need to update it. In this case, it's doing the conversion. And see here that you have more files. We put the second one. We put it here, update, and see that you have mesh 1, mesh 2, you have the location. Okay. Doing the conversion. And we have it. Every now and then save. So now at this point, what we're going to do is just run one of these cases, okay, or both cases. So at this point, I will stop here, okay, and then we move in the next video where we're going to run this simulation. So see you next time. Bye.